In this video, we are going to be starting our chapter on aldehydes and ketones. We are going to be starting off by learning how to identify molecules as aldehydes or ketones. The learning objectives for this entire chapter are listed here. This will be broken down into several different videos, but we are going to be starting off by first identifying molecules as aldehydes or ketones. So what are aldehydes and ketones? Aldehydes and ketones are first carbonyl functional groups. Carbonyl functional groups all have the C double bonded to an O feature in them. There are several carbonyl functional groups, including aldehydes and ketones. You can see the C double bond O feature in both of them. In our next couple chapters, we'll be also introducing carboxylic acids and amides, which are also carbonyl functional groups. And so these are also carbonyl functional groups. It's a carboxylic acid, and this is an amide. And those are also carbonyl functional groups. So carbonyl is just a generic term for C double bond O feature in the molecule. What makes an aldehyde different from a ketone is an aldehyde has a hydrogen at one end. A ketone has two carbon groups. So this one has carbon on both sides. And so this aldehyde has at least one hydrogen. This second R could be an H or a carbon group, but the main feature is it has an H for hydrogen. I like to think of ketones. It sounds like the word key, so if you remember those like old style locks in a door, it kind of looks like that. I'm trying to draw a key. You know, like the old style, old-fashioned locks and keys. It kind of sounds like that. And then this is the C double bond O. So that's what goes on in my head when I picture ketone, is the lock and key. When we represent condensed structural formulas for aldehydes and ketones, we can represent it by drawing out the C double bond O, and this way is really clear to indicate that, you know, there's three hydrogens on this carbon and that we have a C double bond and an H. But sometimes when you're trying to write a message or an email or something, you need to fit it all in one line. So to make this all in one line, the convention is that you write CHO, where the H comes before the O. We have to remember that carbon always has 4 bonds to it. And so if we draw this out, we know that this first carbon has 3 hydrogens. Then we know the second carbon has 1 hydrogen, and then it has an O. Now we can figure out that it has to be a double bond to the O because currently carbon only has 1, 2, 3 bonds. We can't have a double bond to that hydrogen. This carbon already has 4 bonds, so the only thing left is for that carbon to form a double bond to that O. So if we write the functional group as CHO, we can figure out that it is an aldehyde from that. Also, if we write COH, people might think it looks like an alcohol first, and we don't want that. It looks too much like an alcohol. So CHO looks less like an alcohol. Now we have ketones. How do we write ketones? So ketones, the O can be written right after the C. So the O right after the C. And we have to remember that if we had ethers, ethers would have hydrogens on that C. So if we had an ether, this is an ether. Both of these C's have hydrogens. And then here, that carbon has no hydrogens. And so we can again figure out like, oh, that must be a ketone because that carbon has no hydrogens. And so it must be double bonded to that O. If you prefer to draw out the double bond, you can always do this for your structures, unless you're trying to write an email, in which case you can do that. If the groups are the same on both sides, you can group them, but most of the time you would just keep them separate because most of the time they're not the same on both sides. Now when we do line structures, we have to remember that oftentimes, well, all the time in line structures really, hydrogens that are bonded to carbons are not drawn. And so if we try to draw the line structure for this aldehyde, this has 1, 2, 3 carbons. And so that's 1, 2, 3 carbons. 1, 2, 3 carbons. This hydrogen right here doesn't have to be drawn because it's bonded to a carbon. So if you ever see this carbonyl hanging off of the end of a molecule, it must be an aldehyde, because that fourth bond to a hydrogen is not drawn. Oftentimes it is drawn, but it's not necessary for it to be drawn. So sometimes it's drawn, sometimes it's not. For this ketone, you'll see that there's the ketone in the middle of the molecule. So if you see these little lines on the ends that don't have labels, that means that these are C's, not H's. That looks like hot, not H's. So you'd either write the H or leave it off entirely, but if you draw little sticks with nothing written on them, they're carbons, not hydrogens. This brings up another point, that aldehydes are always at the end of your molecule. So aldehyde's always terminal. And then ketones are always in the center. So let's practice identifying our functional groups. Go ahead and pause the video, circle the functional group in each of these molecules, and identify it as either an aldehyde, ketone, alcohol, or ether. Unpause the video when you are ready to check your work. Okay, so for our first one, we have CHO. That is an aldehyde. That's going to be CH, and then our hydrogen can't have multiple bonds, so that O is attached to the C. C needs 4 bonds, oxygen needs 2 bonds. Here we have our functional group here. This is a ketone. We know it must be a ketone because the C has no H's. So it must be that. 2 bonds to other carbons and then 2 more bonds to that oxygen. Here's another functional group. There's our carbonyl, and it's bonded to this point and that point, and so that is a ketone. This molecule has a carbon here, 1 carbon there, but nothing written on the other side. So this is on one end of a molecule. This is an aldehyde. And so this is an implicit H. Implicit because it's not drawn, but implied. Here's some examples of common flavors and odors. Aldehydes and ketones often are responsible for some of the pleasant smells that we encounter in nature. So for instance, cinnamon aldehyde has the odor of cinnamon, and you can see the aldehyde functional group here at the end of the molecule. It also has an alkene functional group and an aromatic group. Here we also have an aldehyde. This is in vanillin. Vanillin has a very strong vanilla-like odor, and so artificial vanilla contains a lot of vanillin. Here you also have a phenol functional group and an ether. I'm just going to label a lot of functional groups. And then aldehyde. For this molecule, this is responsible for the odor of lemongrass. We do have our aldehyde over here. And then we have alkene functional groups. Citronella is a very similar molecule to that lemongrass molecule. It's really only difference in that it's missing that second double bond here. So it does have that double bond, but it's missing the double bond over here. So very slight difference in structure can totally change the smell of the molecule and other properties. Ketones are often found in a lot of beauty care products, such as sunscreens and suntan lotions. So here's a ketone functional group. And you can see it also has alcohol functional groups on both ends. This has ketone, ketone. And so if you look at the names of these, you'll see that it ends with "-one". That stands for ketone. And then benzone, benzone. Benzone means it's attached to a benzene. These are also phenols and ethers. And so if you look at the ingredient labels, you'll often find these kind of suffixes that tell you what functional group is there.